Very well. Now let's see how the rational data works. This is the last part of the module. And we're going to continue using the two packages, mostly deep layer, but we're going to keep the other one also. And let's begin by reading the data that we had before, the crop data. And you can see that there are 7 different columns here. These are the different variables. And we are also going to read this data set, which are the soil data. It's already here in the global environment. You can click here to see more. And in this soil ID, we have 5 columns. It's important for this column that's called soil ID. This is the identification of the type of soil. It's also contained in the crop data. So this is what's going to be used to bind both data sets. You don't need for the name to be the same. Even though the name is different, you don't have to rename it in order to do the binding. But it's necessary for every value here should be the same to the one that exists up here. The function that we're going to use first is the left join. That would be left joint. First, I have the crop data. This is the reference data that I'm going to keep here, and then I'm going to add the soil data in the soil ID column. When I run this part, it's going to give me this data set, all data, that has the same amount of observations that I had in the crop data, but it's going to merge the variables, bind them. So it has the 7 original variables plus another 4 that come from the soil data. And there's one that's the same, so that's why it only takes 4. So I have the 11 columns here. You can see that I have soil ID, yield, and then the 4 additional columns that come from the other data set from soil. That will be the soil structure. You also have the runoff, a soil texture, and the amount of clay, sand, and what's the amount of organic matter. So that's the main purpose of these. Whenever I have columns from a data set that I need to have in another data set, and if I have a variable or a key that can be used to do this relationship between both of those data sets. Just to keep another example and another way to use these functions. So I've created a data set here for soil that does not include all data. It just has the data of low organic matter. So I don't have the 72 types of soil, but I only have 30 different types of soil. That are selected with this filter. So if I use the same command as before, but now with this data set, let's see what's going to happen. I still have the same amount of observations because this depends on the data set that's on the left, and the amount of variables because I didn't change the variables. But what happened then? What's going to happen here is that for the data that does not exist in the right side data set, they're going to be not available as NA, not available. So when the left join command is used and the data set on the right, it does not have all the keys, the ones that do not exist are going to be shown as not available or NA. If I'm interested only in the data that I have in both, if I want to maintain only the data that have coincidences, we can use the function called inner join. This will be the internal join or inner join. So I'll run it here. And by doing this, you can see that my data set where I have everything joined, but only with the ones with low organic matter, I have 320 observations. So it's filtering and removing all the rows that do not have any observations in the soil. So we're not going to have the NA values anymore. So that's why we have these different versions to do the join depending on what we need and what we want to contain. And just to finish, I personally do not use this very often, but it's good to know how to use it. This is a function to do everything at the same time. So if I only want to filter, I don't want to join the columns. I don't want to bring columns for another data set, but instead of this, I want to filter a data set based on the other, and I don't want to carry out a join function and then remove the columns. What can be done is to use this function that's called semi-join, which is going to do exactly that. So I have the same arguments, and now my data set has the same 320 observations. There's a it, the soil information rows were removed, but it has 7 variables. The difference with this function is that I'm not going to bring the information from the other data sets. I'm just going to use it to do filter. I mean, I don't need to have the information of the soil here, for example. So these are the other types of joins that we have in the theoretical part. This is an example of that. And I know that it's not too easy to do this for the people that are probably more experienced with relational data and SQL with these type of data sets. It's probably easier for you to understand. But for the others, I know it's going to be a little bit complicated. So my recommendation is to pay a lot of attention to everything that you have in the links, because it's probably broadly explained there with more detail than this presentation.